Hi everyone, my name is Ayush and I will be giving an overview of the VQA Challenge 2021 and present some interesting analysis from the challenge. We are a growing community, so for those of you who are new to VQA, I will first recap the task definition in the VQA dataset. Then I will talk about some logistics for this year's challenge and then I will announce the results and finally we will go over some interesting analysis of the results. So let's start with the task definition. Given an image and a natural language open-ended question such as what is the mustache made of, the task for an AI system is to generate a natural language answer such as bananas. The VQ dataset contains more than 200,000 images from Coco, more than 1.1 million questions, and more than 11 million answers. In the VQ dataset, for every question, there are two images that look similar to each other, but the answer to that question for both images are different. For example, for the question, who is wearing glasses, the answer to these similar images are different, man and woman. So the model really has to understand the subtleties about the image to answer the questions accurately. The accuracy metric counts how many of the 10 ground truth answers are same as the prediction. If 3 or more, the prediction gets full credit, otherwise it gets partial credit corresponding to the number of ground truth answer it matches. So that was about the task and the dataset. Now let us look at some details about the challenge. This year, the VQA challenge was posted on Evalai, same as the last 4 years. The training set consists of 80,000 images and 443,000 questions. The validation set is about half the size of the training set. The test set is about the same size as the training set. The test annotations are not publicly released. Now let us look at the test set in more detail. The test set is divided into 4 splits of approximately equal size. The test depth split is for the purpose of debugging and validation. The test standard split is for public leaderboard. It has a limit of 5 submissions and maximum 1 submission per day. This set is also meant for reporting numbers in publication and comparing with other methods. Test challenge is the split used to decide the ranking of the challenge participants. And the test reserve split is used for making sure that there is no overfitting. Scores on this split are never released. Now it is time to announce the winners. But before I announce the winners, I would like to mention that this year we saw continued high participation with 55 teams participating in this year's challenge with individuals from more than 10 institutions. So the winner team for this year's VQ challenge is Alice Mind, and the team members are Ming Yan, Hai Yang Shu, Chen Liang Li, Jun Fang Tian, Wei Wang, Bin Bi, Zheng Kao, Ji Shang, Song Fang Huang, Fei Huang, and Luo Si, and their accuracy on test challenge split is 79.78. Now I will present some interesting analysis based on the challenge results. This plot shows the challenge accuracies for all challenge participants. The green bar is the winning entry from VQA Challenge 2020. So we can see that 10 teams were able to beat the winner entry of last year's challenge. And there is a 3.42 absolute improvement in the performance compared to the last year's winner. In order to find whether performance of team are statistically significantly different from one another, we performed Wilcoxon signed rank test, which is a non-parametric version of the paired t-test. It tests the null hypothesis that whether two related paired samples come from the same distribution or not. We tested this for 95% confidence. This plot shows groups of teams that are statistically similar in same colors. We found that the winner team is statistically significantly better than the runner-up team. Recall that the VQ dataset has two images with the same question but different answers, and these images are very similar to each other. We call these images complementary images. So, given such a dataset, it is interesting to analyze if the models are sensitive to subtle changes in these complementary images. So, in order to answer this question, we analyze whether the model produces accurate predictions for complementary images. We compute the accuracy of each model where the accuracy metric is how many complementary pairs it got right. Under this metric, if the model predicts correct answer for both images, it gets 1 point. Otherwise, it gets 0 point. So we plot this graph and we can see that the top teams get about 70 to 75% of the pairs correct. Interestingly, we see that the best performance decreased by about 3.5% from last year. It has been shown in recent studies that today's VQA models are heavily driven by superficial correlation in training data. So it is interesting to ask how much are the current entries driven by priors in training data. In order to answer this question, we compute the accuracy over those questions whose ground truth answers are not top 1% most common answers for the given question n-gram in training. These questions consist of about 73% of the whole test challenge questions. In this plot, we show the accuracies of all entries for non-one prior questions and we compare this against the accuracies for all questions. We see that there is a drop of 5 to 6% in performance. Comparing this with last year, the best performance for non-one prior questions improved by 3.84%. Another interesting question to ask is how good are current models in answering questions that are compositionally novel? So what we mean by this is that the test QA pairs are unseen in training, but the concepts in the QA pair are seen. Suppose at test time the question is about red plate and you have not seen red plate during training, but you have seen a green plate and a red stoplight during training. So by compositionality, I mean the ability to compose the concepts of plate and red to be able to recognize red plate at test time. Here we look at the accuracy of teams for such questions. We see that the performance of all models dropped by 10 to 14%. We also see that the best performance improved by 3.31% from last year. Thus, we saw that there is still room for improvement on this front, but we are making progress. We have been running this challenge for 6 years, so let's zoom out a little bit and look at the progress in VQA. This plot shows the state-of-the-art performance on the dataset with time. Our baseline model from ICCV 2015 is shown at 55.3%. The human performance is shown at 80.78%. During Challenge 2016, the accuracy improved by 7%, followed by 2017 Challenge where the improvement was of 6.7%, followed by 2018 Challenge with an increase of 3.4%, followed by 2019 Challenge where the increase was 2.9%. And in last year's challenge, the accuracy improved by 1.1%. And finally, during this year's challenge, the accuracy improved by 3.4%, going from 76.36 to 79.78, where the state of the art is right now. The rate of improvement during this year's challenge has been significant, bringing the current VQA models very close to the human performance. That's all I have. If you have any questions, please join our live QA session at noon PT June 19th or midnight PT June 20th. Thank you.